Hello and welcome to Statistically Significant. In today's video, I will discuss how to perform a two-way Anova with more than one observations per cell using Rstudio. So we are given a data set on the birth weights of the infants and we are to test three hypotheses here. Our first null hypothesis is that there is no significant effect of the order of gravita on birth weights against the alternative that there is a significant effect of the order of gravita on the birth weights. Now the order of gravita, the term means how many times a woman has become pregnant. When order of gravita equals 1, this means the woman has become pregnant only once. When the order of gravity is equals to 2, the woman has become pregnant twice, and so on. Our second null hypothesis is that there is no significant effect of the age of the mother on the birth weights against the alternative that yes, there is a significant effect of the age of the mother on the birth weights. And our third null hypothesis is that there is no significant effect due to the interaction of the two factors against the alternative that yes, there is a significant effect due to the interaction of the two factors. Now let's have a look at the data in hand. This pink section, highlighted section, is the data which is given to us initially. The small a, b, c, d and e are the order of gravita, where a means order of gravita is equals to 1, b means order of gravita is equals to 2, and so on. And capital A, B, C, D and E, they are the age groups of the mothers. A means the age of the mother is in between 15 to 20. B means the age of the mother is in between 20 to 25, and so on. Now you could see that corresponding to the two factors here, we have more than one observations per cell. Okay, now you might say that they are three different cells, but that's in Excel. But actually, the data was given like this: that corresponding to the two factors, we have more than one observation here. We have three observations per cell here. So, as we have replications here, we have to consider the effect of interaction of the two factors, which is influencing our response. So we have to consider the effect of the interaction of the order of gravida and the effect of interaction due to age group of the mothers. Okay, but if we use this data, R won't be able to extract it very swiftly. So we have to enter the data systematically so that R can easily read into it and perform the analysis swiftly. In this file, I have entered the data in a manner in which R would be easily able to differentiate the different factors and the response. Our response is the weight of the infants, and the two factors are order of gravida and age of the mother. Okay, you could see we have 75 observations here. These are the birth weights, weight of the infants at birth. So now we're going to use our Studio to perform the analysis of variance. For this, we use the read.csv function and just have a look how R has read it. You could see that R has read the data as similar in the Excel sheet, and R is taking the weight of infants as a numeric variable, which is okay, but R is taking the age of the mother and the order of gravita as character, but they are not character, they are factors which are influencing our response variable. So we need to convert them, and you guys who have seen my previous videos, I have shown how to convert character into factor. We use the as.factor function, and it's very simple. Sorry. Yeah, now it's okay. No problem. Now you can have a look. R is considering the age of the mother as a factor with 5 levels, and it is also considering the order of gravida as another factor with 5 levels. Now we can use the AOV function to conduct an Anova test, two-way Anova test. Now let me give it a name, birth weight. I use the AOV function. First we enter the formula, and the formula is our response, which is being influenced by factor order of gravida plus another factor age of the mother and their interaction. Just have a look how I have entered the interaction part. It is the most important part in this analysis, and now we have to tell which data are we using while we are using the AOV function, and just use the summary function to get the Anova table. That's it. We have got our Anova table here. Just have a look. Now we have 5 levels of the factor order of gravida, and the degrees of freedom becomes 5 minus 1, 4. We have 5 levels of the factor age of mother. The degrees of freedom becomes 5 minus 1, 4. The interaction part is just a product of the DFs, 4 into 4, 16. Totally we had 75 observations. Total DF then becomes 75 minus 1, 74. Now when we subtract 16 plus 4 from 74, the remaining DF, the error DF becomes 50, which is here the residuals. So this is the sum of squares, the mean sum of squares, the F values, and the most important part is the P value here. For the factor order of gravida, we could see that the P value is much less than our alpha value, which is by default 0.05. So in this case, we could see that as the P value is less than 0.05, we failed to accept the null and consider and conclude that yes, there is a significant effect of the order of gravida on the birth weights. Similarly, for the factor age of the mother, we could see that the P value is again less than 0.05. So in that case as well, in this case as well, we conclude that yes, there is a significant effect of the age of the mother on the birth weights. Now, for the interaction part of the two factors, order of gravida and age of the mother, we could see that the P value is way higher than the alpha value 0.05. So we conclude that there is no significant effect due to the interaction of the two factors on the birth weights of the infants. So this is how we perform a two-way Anova with more than one observations per cell. I hope you guys have understood. Do like, share and subscribe. Thank you.